on Kiwi. Dylan Storey now steers into space as he does this time every Friday on the show. Thanks very much to the Auckland Stardome Observatory. Good morning, Dylan.
Good morning, Wimbo.
And first story this morning. This might be concerning for all residents of planet Earth. Are we doomed? NASA is looking at another close pass by an asteroid.
Yeah, well, I'm sure we are doomed, but not because of this. Because this is an asteroid which is making a close pass. And by close, I mean 324,000 kilometres, which is actually pretty close. It's 85% of the distance to the moon, so it's closer than the moon.
Wow, that is so really. I mean, that's very, very close. That is a close pass.
It is a close pass, but it's happened many times because this asteroid is sort of fixed in this orbit that goes around the sun and passes Earth regularly at a similar distance, even though this is the closest it's been in at least 2 centuries. The last time it passed was in 1976, and no one even noticed it. So,
Okay.
for one thing, it shows the effect it has, and it shows how far we've come in being able to detect these bodies.
Yeah. How big is it?
400 metres across. So NASA are comparing it to the size of an aircraft carrier.
Well, that's significant. Yeah, I mean that would, if that entered the Earth's atmosphere, it wouldn't all break up, would it?
No, it would hit. It would be like a almost species extincting event.
Wow. Okay.
Yeah, it probably would, but it's not going to. It's going to pass by.
Well, so they say, Dylan. So they say.
Yeah, so they say. Well, there are conspiracy theories around it, of course, as there are with all these things.
Yeah.
But the conspiracy theories are saying that the gravity is going to cause tsunamis, earthquakes, whatever. Take your pick of terrible event. But the fact is that it's not.
Okay.
It's just not big enough to have that much gravity.
It must be being influenced by Earth's gravity, though, right?
Absolutely. It's I mean, these things have been going around in the solar system for billions of years, and so they've sort of established a gravitational resonance. If it was going to have crashed into Earth, it would have a long time ago. That's not to say that something couldn't in the future, some rogue object, but they've sort of established this sort of mutual passing by swinging orbit. So yeah, it is completely dependent on Earth's gravity, but it's in this sort of codependent relationship, if you like.
Okay. I'm concerned because Bruce Willis is getting on a bit. We need to replace him as the potential dude to send off to solve a potential catastrophe.
That's a point. Who are we going to use?
I don't know who's the equivalent these days.
Well, something interesting about this asteroid that isn't in any Bruce Willis movie is that it's a Type C asteroid which is made up mostly of carbon, so it's actually very dark. It's darker than charcoal.
Okay.
So that's why it's so hard to detect, and that's why we've only sort of detected it now with modern technology. So they didn't show that on Bruce Willis movies. I don't know how he'd cope with that.
Yeah. So being so dark and made of carbon, if it did fall to Earth and we survived, it could be useful?
No, I don't think so. You mean like burning it as coal or something?
Something like that.
With the 1% of the human race that are left alive?
Yeah.
No, I think it would just. I think the impact of the collision would sort of completely merge it with the Earth, perhaps turn them both molten in the area. I don't know, maybe in a few 100 million years, it could form a coal seam under the ground.
Wow.
Where the new race of humans mixed with machines can eventually...
Okay, moving on. So when's that happening? November the 8th, is it?
Oh, November the 8th, yeah, that's when that's passing by. So it's mainly being watched by radio telescopes. And radar won't particularly be visible. A
tweet from Hugh this morning says he volunteers Winston Peters to replace Bruce Willis as the dude to go out there and save us from the asteroids.
It could be on something there.
Yeah. Okay. Let's move on to Venus. What's going on there?
It's quite interesting that one of the probes around Venus has discovered an ozone layer around Venus. So as we know, it's the ozone layer which allows life, at least life as we know it, to exist as we know it on Earth, because it filters out a good part of the ultraviolet radiation from the sun. Ultraviolet radiation has the frequency which disrupts molecules which are handy to biological life.
Yeah.
So getting rid of it is important for life to, if not exist, then at least develop. So it's been found around Venus, and the way they found it is by looking at stars through the sides, through the edges of Venus's atmosphere, and measuring the light from them and noticing that some ultraviolet radiation has been absorbed from the background stars as it passes through the edges.
Yeah.
So it's quite an important detection, and they've managed to also map out its distribution and its thickness, and find that it's much, much thinner than Earth's. It's something like hundreds of thousands of times less than Earth's. So it's the current theory on the formation of ozone is that it started off in Earth's evolving atmosphere, where oxygen molecules caused the first ozone molecules to form, and then after a certain point, it was perpetuated by biological life, be it plant life or animal life. So I think the model's pretty vague, but the estimate are that ozone layer has to be at least 20% that of Earth's to have been caused by biological life.
Okay.
So Venus's is not enough to have been caused by biological life. But what that means is that gives us something to look for on exoplanets, or planets around other stars. When we're detecting their atmospheres,
Right.
if we find an ozone layer with a thickness of more than 20% of Earth's, then that's going to be a big sign that it's been caused by biological life.
Huh.
So when we're looking for life on other planets, this gives us another tool in our arsenal.
Cool. So it becomes part of the checklist that we look for, because we've talked about other things, haven't we? Like sort of the different light that these planets can give off indicates what sort of minerals are there, and this is just another thing to add to the checklist of looking for these planets.
Yeah, that's right. The other two important things are the presence of carbon dioxide and presence of water, which can also both be detected in the atmosphere. So, so this is using occultation of stars, or partial occultation. So when the star goes behind the layer of atmosphere right on the edge, planets around other stars, the ones that are discovered by the effect they have on their star as they go in front of it, it's a similar effect. So we'd be looking at the light from the star and how that light changes as the planet goes in front of it, or as the planet's atmosphere goes in front of it, what that does to the light behind from the star.
Okay.
But as you can imagine, a planet transiting a star is tiny as a tiniest little dot going across a star.
Yeah.
So that the fraction of light that it's changing is going to be tiny. So you can imagine the sort of how sensitive these instruments have to be to measure this sort of thing.
Is that's what Hubble looks at, isn't it?
Only partially. It's sort of not specialist in that. Hubble's there as visible light. It does have some spectrometers that they need to do that. So Hubble's sort of set up. It's got some sort of spectrometer for general spectroscopy. But for something of this precision, it really needs a dedicated instrument, or something, a special planet-finding instrument, which they've got on land-based telescopes. And I'm not sure, there's the James Webb Space Telescope, which is planned to be launched in 2015, which is much bigger than Hubble. And I assume there'll be something dedicated to this sort of detection on the James Webb. I'm not sure.
Oh, cool. Well, that's positive news coming from Venus. Well, Dylan, thanks very much for joining us this morning. Don't forget you can steer into the stars, as Dylan does, over at the Auckland Stardome Observatory if you're passing by there as well. Thanks very much.
Thank you, Emma.
It's now 8 minutes away from 8 here on Kiwi, coming up after 8 o'clock. Going to be